Hi, everyone. Welcome to lesson R7. So this is going to go along with some take-home notes that you would have gotten in class. And remember, chapter R just stands for review. So we're doing sort of a brief review of some exponent rules and properties of exponents, and we're going to build on this later on in the class, especially when we learn more about square roots and radicals and things like that. All right, so we have some properties or rules with exponents. The first two you can see on the screen. We have the product rule and the quotient rule. So the product rule, remember, product has to do with multiplication. When we have a product of two expressions or two numbers that have the same base, so you can see this a here is the same base. What we do is add the exponents. So a to the m times a to the n is equal to a to the m plus n. So a quick example of this would be if you have x to the power of 2 times x to the power of 3, the answer would be x to the power of 5. So you would add those exponents, 2 plus 3 equals 5. That's the product rule. Quotient rule is kind of the opposite. So when you have a quotient or a division problem, which will look like a fraction, instead of adding the exponents, we're going to subtract them. And it's important that we subtract the top exponent minus the bottom exponent. So here's a quick example. If you have x squared over x to the third, what we can do is subtract those exponents. 2 minus 3 is equal to -1. Which brings us to our next property. So I'm going to need to scroll down to show you more of the notes here, but there's another rule or formula, I guess you could think of it as a formula, that tells us what we need to do when we come across negative exponents. So we're not going to leave our answer with a negative exponent. It's important to rewrite it in a different way with a positive exponent. So keep this in mind. I'm going to erase what we've written so far. X to the -1, there's a way of rewriting that. Okay, so I'm going to clear my writing here, scroll down. Here's our official formula with negative exponents. So an expression with a negative exponent can be rewritten. If you have x to the -n, we can rewrite that as 1 over x to the positive n. So I want you to keep a couple of things in mind. First of all, of course, we're rewriting the negative exponent as positive, and then you're kind of flipping the expression. That's not really a technical term, but here, let's see. So I'm going to just write those things down. So flip, and then change to positive. Oh, and you know what? That's already typed for you, but we're writing it again. All right, so with x to the -1, notice in the other expression, I did write a +1 in front of the expression. 1x to the -n is equal to 1 over x to the +n. I put that 1 here so you know that whatever number is in front of your expression needs to stay there, needs to stay in the numerator. The only thing that's getting flipped, to use that word again, is anything that has the negative exponent. So our expression x to the -1 gets rewritten as 1 over x to the +1, which we can just write as 1 over x. And just to bring it back to where this example came from, let me erase this again. Remember, we got that answer when we did x squared over x to the third. Think about what happens when you write this out. X squared is x times x, and then x to the third, x times x times x in the denominator. And then think about canceling out common factors, right? Canceling out factors that are the same. And remember, when you divide something by itself, it equals 1. So if you cancel out a factor of x in the numerator and denominator, x divided by itself would equal 1. You can do that again with another pair of x's. So really what's left in the numerator is just 1 times 1, which is 1. And then we do still have that x left in the denominator. So there's our 1 over x. Anyway, with any of the exponent rules that we review, keep in mind there's often ways to sort of reason your way through. If you forget, wait, do I add or subtract or multiply? What do I do? If you write out the expression from exponential form, kind of in this longer form, sometimes you'll be able to remind yourself what rule makes the most sense in that scenario. Okay, so we have some more examples down below here. We have a multiplication and then a division example. So 2a squared b to the -3 times 3ab. You can see this problem already written out. Basically, we're multiplying the coefficient numbers together. 2 times 3, that's going to be 6. And then we're using the product rule. We're adding exponents when we multiply our variables. So with the a's, a squared times a, you're basically adding those exponents 2 plus 1 and getting a to the third. And then, of course, our powers of b, here's a negative exponent again. -3 plus 1 is going to be -2. Now notice we don't leave our answer with a negative exponent. We have to take that, whatever expression has the negative exponent, flip it and change the exponent to positive. So notice that the final answer is written as a fraction. The 6 and the a to the third are still in the numerator, but that b to the -2 is now b to the +2 in the denominator. So our final answer has all positive exponents, 6a to the third over b squared. Let's look at a dividing example. Dividing problems really just look like fractions a lot of the time. So think of it as reducing a fraction or simplifying a fraction. So here's our dividing example. -8 x to the -7 y to the fifth over 2x squared y to the third. Think of it like 3 separate problems that you're working on. So first, the coefficient numbers. You're going to divide -8 divided by 2, and that's -4. Sometimes students get confused about flipping when you have a negative number. The whole thing we just worked on with negative exponents, that's only applying to exponents. So when exponents are negative, that's when your expression can kind of flip. Negative coefficient or just negative numbers like a -8 or a -4, just those are fine. Just leave them as they are. So -8 divided by 2, -4, no problem. Now with the x's, we're going to subtract those exponents, -7 minus 2, and that's -9. So we'll have to deal with that in just a minute because that is a negative exponent. And then of course the y's, y to the fifth divided by y to the third, we subtract 5 minus 3 and get +2. So once again, notice that really there's only one expression that has a negative exponent, and that's the only one that's getting flipped to the denominator of the fraction. So x to the -9 is now x to the +9, but it's in the denominator. Everything else stays where it was. Our fraction is still negative. We still have a +4 now in the numerator, and then a y squared. I personally might write this in a slightly different way. I know I just said +4, that might have been a little confusing. So another way you can write this is keep the -4 just exactly as it is and just kind of stick that negative sign in the numerator of the fraction. That is completely fine. So you can kind of pop it out to the left like you see typed here, or you can write that negative sign in the numerator. Both of those are correct. As long as it's there somewhere in the final answer, we're good. And once again, our final answer has all positive exponents. Okay, so let's move to the next page. All right, so here's another example with multiplying, and then we'll do another example with dividing as well. So I'm going to leave the your turns as problems you can try on your own. We're just going to do the regular examples. If you are watching this because you're in my 13-15 class, then you have the handout. The notes handout already, and I do have an answer key for all the problems. If you want to try the your turn and check it on your own, go ahead and do that. All right, so here's another multiplying example. -5 x to the -5 y to the 10th times 4x to the third y to the 7th. So just like the previous problems, we're going to start by dealing with the coefficient numbers. In this case, we'll multiply -5 times -4, which is -20. Next, let's multiply the powers of x. So x to the -5 times x to the third. So we'll add the exponents. -5 plus 3 is going to be -2. So I'm writing x to the -2. And then finally, we have our y's, y to the 10th times y to the 7th. Add those exponents, 10 plus 7 is 17. So we have -20, x to the -2, y to the 17. Our final answer needs to have all positive exponents. So any expression that has a positive or has a negative exponent needs to be flipped to the denominator, and the negative exponent will become positive. So that means we're going to have a fraction in our answer. Anything that doesn't have a negative exponent, just keep it where it is. That means it's going to stay in the numerator. So I'm going to keep my -20 and y to the 17th and rewrite those in the numerator. Meanwhile, the x to the -2 now becomes x to the +2 in the denominator. And here's our final answer, negative 20 y to the 17th over x squared. Or you can, let's see, you can write the negative sign directly to the left of the fraction. So negative in front of the fraction, and then 20y to the 17th over x squared. Just slight little differences in how you can write it. You'll see it typed either way. Sometimes we put the negative all the way to the left of the fraction. Sometimes we keep the negative in the numerator. Both of those are correct. But what's important is that all the exponents are now positive. Okay, so let's see a dividing example. So it looks like a fraction, negative 24 m to the 6th n to the 8th over negative 8 m to the 5th n squared. Again, think of it kind of like 3 separate division problems or reducing problems. Let's start by dividing negative 24 divided by negative 8. That's positive 3. Then next, let's deal with the powers of m. Remember, we're subtracting exponents. 6 minus 5 would be 1. So I'm going to write m to the 1, or really I can just write m. And then finally, the n's, n to the 8 divided by n squared. I'm subtracting 8 minus 2, which is 6. So this problem is actually quite a bit shorter than a previous example because we do not have any negative exponents, so we're done. There's no need to rewrite anything. It's as simplified as it's going to get. Okay, very good. So those are some examples of using the product rule and the quotient rule, multiplying and dividing. Next, we're going to see an additional exponent rule called the power rule. So if you're taking the power of a power, so to raise a power to a power, what we do is multiply the exponents. So a quick example of this would be if you have x squared to the 3rd, instead of adding the 2 and the 3, like we've seen previously, we would multiply the 2 times 3 and get x to the 6th. Okay, so that's an example of the power rule. All right, if you have more than one variable or more than one number in your parentheses raised to a power, I kind of think of it like you're distributing that power. So you're sort of applying that power to everything inside the parentheses. So the formula goes like this, in parentheses, ab to the n. You can rewrite it as a to the n times b to the n. Same thing with a quotient. If you have a fraction, a over b to the n, sort of distribute that exponent, you have a to the n over b to the n. You have this little note here that says b is not equal to 0. That's just reminding us that we can't divide by 0. We don't want to have something be undefined. So it's just a little note saying, hey, this only works as long as your denominator isn't 0. Okay, and then there's another rule here, again, related to negative exponents. A over b to the negative n, we can rewrite that as b over a to the positive n. So we can still kind of follow those same 2 procedures with negative exponents, where something gets flipped, and then our exponent changes to positive. Just writing that here. So when you have a whole fraction in parentheses raised to a negative exponent, flip that whole thing, and then change the exponent to positive. Okay, we see some examples of the power rule down below. Let's take a look. So our first one is y squared to the power of 6. All we do is multiply the exponents, 2 times 6, and we get y to the 12th. Now, it would be kind of a pain to do this, but one option is you could actually write this out, y squared to the 6. I might run out of space here. I'm writing it out. 1, 2, 3, 4, 5, and 6. So yeah, it gets a little tedious, a little bit messy, but you can write out y squared 6 times. I could even make this even more detailed, and in each of those parentheses I could write y times y, y times y, y times y. Basically, it's a way of writing out and proving to yourself that yes, in fact, there are 12 powers of y, not 8. So a common mistake here is to add the exponents, but we just learned with the power rule, what you want to do is multiply the exponents. Okay, next example. Negative 3, x to the 4th, y to the negative 2, all in parentheses to the power of 4. So notice how we're applying the power rule here, and we're essentially applying that exponent of 4 to each piece or each term, each number, each letter in the parentheses. Negative 3 to the power of 4, x to the 4th to the power of 4, y to the negative 2 to the power of 4. You can use your calculator. Negative 3 to the 4th, negative times negative becomes positive. Any even number, any even power of negatives will become positive, and we get positive 81. X to the 4th, we multiply those exponents. 4 times 4 is 16. -2 times 4 is -8. So there's that y to the -8. And then notice how we rewrite it as y to the +8 now in the denominator of a fraction. We've seen that before. Okay, last example in this little set, we have an entire fraction raised to a negative exponent. So this is where we flip the fraction and then change the exponent to positive. So notice that the 3x to the 5th moved to the denominator, the y squared moved to the numerator, and then our outside exponent is now positive. From there, you can use the power rule, essentially distributing that exponent to every expression in the parentheses. Y squared to the power of 2, we multiply 2 times 2 and get 4, so y to the 4th. 3x to the 5th, all squared. Now keep in mind what's happening here is the 3 is getting squared and the x to the 5th is getting squared. So just be careful that you're not doing 3 times 2 and writing 6. The 3 is a coefficient number. We just want to actually square that one. Whereas if you had an exponent like 5, x to the 5th squared, that's where you would multiply the exponents. So you're squaring the number and then multiplying the exponents. So 3 squared becomes 9, x to the 5th squared, because 5 times 2 is 10, we get x to the 10th. And here's our final answer with all positive exponents, y to the 4th over 9x to the 10th. All right, doing great. Let's take a look at some power rule examples with negative exponents. Okay, here we go. So our next example is in parentheses, -2, x to the 6, y to the -2, z. And all of that is raised to the power of -3. Okay, so there's a few different approaches we can take here. I think I will start in the same way that we've seen before and distribute or apply that power to everything in the parentheses. Just keep in mind, we are distributing this negative power, so we're going to have kind of a mess to clean up. We're going to have a lot of negative exponents, but we'll be careful about simplifying each of those. So -2 to the -3 times, now x to the 6 to the -3, that now becomes x to the -18th. And then y to the -2 raised to the power of -3, that now becomes y to the +6. And then we have z to the -3. Okay, so we have 4 different letters or numbers here. 3 out of 4 now have this negative exponent applied to them. So let's rewrite this expression as a fraction. Anything that had a negative exponent is now going to move to the denominator. So really the only thing that stays in the numerator will be that y to the 6, because that y to the 6 is a positive exponent. Everything else is getting rewritten in the denominator. So -2 to the -3 now is going to be rewritten as -2 to the +3 in the denominator. This is our sort of flipping and then changing the negative exponent to positive. X to the -18th is now going to be x to the +18th. And then z to the -3rd is now z to the +3rd, but again, in the denominator. Okay, I'm circling what we have so far. We're almost done, but not quite. The last thing we need to do is actually simplify -2 to the 3rd. Everything else gets rewritten. So we do still have y to the 6 in the numerator. -2 to the 3rd, -2 times -2 times -2 is -8. And then, of course, we still have x to the 18th, z to the 3rd. So here's our final answer. It's a fraction, y to the 6 over -8, x to the 18th, z to the 3rd. And that negative sign that you see in the denominator, you can leave it right there, or if you prefer to rewrite it sort of off to the left side of the fraction, sort of off to the side, that is also fine as long as it's somewhere in the answer. But I'm just going to leave mine where it is. Okay, so I mentioned there was another way, or at least one more way to do this one. Another option would be you could actually have flipped the entire expression first. For the sake of not confusing everybody, I'm not going to go through the problem again. I think just stick with what we just did. If you have another approach that you tried and you still got this exact same answer, you're good. Otherwise, I would say stick to what we did here. Use that power rule and then sort of take it one piece at a time, noticing whether the exponents are positive or negative in terms of whether to flip your expression or not. All right, very nice. Let's see. This next one will be a little bit shorter. We have a fraction raised to a negative exponent. So I think in this case, again, we have some choices. We can do what I just did and distribute that -2 to everything. But remember, we had that rule, just remind us, if you have a over b to the -n, remember, you can just flip the fraction b over a to the positive n. I think that will be the easiest approach for us to do here. So let's take this whole fraction. Because it's being raised to a negative exponent, let's flip the whole thing and change that -2 exponent to a +2. And I'm going to rewrite everything else inside. So the 3x to the 5th is now in the denominator, and the y squared is now in the numerator. Okay, this problem looks really familiar. I feel like we already saw this example, but that's okay. We'll redo it. Okay, so y squared to the power of 2. 2 times 2 is 4, so y to the 4th. 3 squared is going to be 9, and then x to the 5th squared will be x to the 10th because we're multiplying those exponents. There you go. If it's not exactly the same, this is so similar to a previous example we saw, I think, on the previous page. All righty. I think we're doing pretty good here, and we've made it to the practice exercises. So I'm going to end the video here. Again, if you're watching this in my class, we will be doing some of the practice exercises together in class, but mostly it's kind of up to you if you want to try some on your own. And again, I will provide an answer key so you can check your answers as you're practicing. Okay, thanks for watching, and let me know if you have any questions. Thank you.